All right, let's do question number 8 on this review problem set. And it says, is this function differentiable at x equals 2? Okay, so at x equals 2, notice you've got a break in the graph between these two pieces. So one thing you can do is, if it's simple enough, is just graph it. So let's actually just do a quick graph of what we see here. I notice that's the y equals 3 is the y-intercept of that. It has a slope of -1. So I think it will be fine to just do this. Y equals 3 is the y-intercept. And it is this line up to x equals 2. And we color in that endpoint there. Now let's look at this parabola. So a precondition to being differentiable is it has to be continuous, but it can't have any corners or have a vertical asymptote, and clearly it can't have any discontinuities. So let's make sure it's continuous at least, and let's graph this parabola part for x greater than 2. Now, the vertex of this parabola would be at 2, 1, but that's actually right here at this endpoint. And if I go right 1, I go up 1, go right 1 more, I go up, let's see, go up 4, 1, 2, 3, 4. So it would be about right there. And it's going to look like this. All right. Now that you have this graph, is this differentiable at x equals 2? Heck no. This is a corner. The graph on the left, what would the left derivative be? The derivative on the left of this point is -1. The derivative coming from the right is actually 0. Let me see if I can draw this slightly better. So on the right side, it's a parabola and it's horizontal right when it gets to this point at the bottom. So from the right, the tangent lines are approaching 0. But from the left, the tangent lines are always -1. So the g prime at 2 does not exist as a limit. G prime of 2 is undefined if we think of the derivative as a function. So g prime of 2 does not exist because the graph has a corner. Okay, is there another way we can engage with this? So by the way, what I just did is totally fine. So if you can graph it and show that there's a corner, you're done. Or if it's a multiple choice question or something and you just need to figure out what the answer is, you can do whatever you want. So if graphing works for you, great. How could we try to figure out the derivative of this? Well, the derivative of this, g of x, g prime of x, would be the derivative of each piece. So on this piece, it would be -1. The derivative would be -1 for x less than or equal to 2. Well, we got to be careful about the or equal to because we don't know if the derivative will exist at the break. In fact, we know it doesn't exist at the break. And the derivative of the bottom thing, if we multiply this out, it would be 2x minus 2 plus 0. So just 2x minus 2. And, how would we get that? We get x squared minus 4x plus 4 plus 1. So this would be x squared minus 4x plus 5. And the derivative of that, I'll do it that way. Since we're not doing chain rule on this test, the derivative of this would be what? 2x minus 4 for x greater than 2. Now, if I were to graph the derivative, I would get -1 all the way up to 2. And then I would get 2x minus 4. Well, 2x minus 4 Yeah, 2x minus 4 would be what? So then I've got what? The -1, -2, -3, -4. And the right piece would start here and have a slope of 2. So I'd go right 1 up 2, right 1 up 2. And, but I'm only graphing this for x greater than 2, so the derivative would look like this. Okay, so what I've done is I've graphed 2x minus 4 over here, and I've graphed y equals -1 over here. So the derivative looks like this. Well, the derivative has a jump in it. So the derivative is not defined where there's a jump. And another way to think of that is if I take the limit of the derivatives as x approaches 2 from the left, the slopes on the left-hand side of the graph are all -1. The slopes on the right-hand side are all determined by 2x minus 4. So as x approaches 2, this derivative approaches 2 times 2 minus 4, which is 0. So on the right, we're getting derivatives that are approaching 0 at 2. And on the left, we're getting derivatives that approach -1 at 2. But that actually goes with what we said about the graph of the original function, or the graph of g. The slopes on the left-hand side are -1. The slopes on the right-hand side are approaching 0. So no matter what way you look at it, the derivative does not exist. So this was a totally sufficient answer to just graph it and see. You can take the derivative of each piece and do a left and right hand analysis. And but in either case, the derivative does not exist. Add 2.